In 1966, while Ford and Chevrolet were busy building pushrod V8s, Pontiac did something revolutionary. They introduced America's first mass-produced overhead cam engine. Not in a limited production sports car, not in a race-only special, but as the base engine in the Tempest. And it wasn't just overhead cam. It used a fiberglass-reinforced timing belt decades before Honda made it mainstream. Today, we're diving deep into the Pontiac OHC6, an engine so ahead of its time that most people don't even know it existed. This is the story of brilliant engineering, corporate indifference, and what might have been. To understand why Pontiac developed this engine, we need to step back to the late 1950s. Like most American automakers, Pontiac had jumped headfirst into the V8 revolution. In fact, they were so committed to V8 power that they dropped their old flathead six-cylinder engine completely after the 1954 model year. For the next decade, if you wanted a Pontiac, you were getting a V8. But then came 1961 and the compact car craze. Pontiac introduced the Tempest, and here's where things got interesting. Instead of using a conventional six-cylinder like every other compact on the market, Pontiac took their 389 cubic inch V8, literally cut off one cylinder bank, and created a 195 cubic inch inline four-cylinder. They called it the Trophy 4. It was unbalanced, it vibrated like a paint shaker, and it needed a special rubber-mounted drive shaft just to keep it from shaking itself apart. By the early 1960s, it was clear that Pontiac would eventually need a proper six-cylinder engine. The Trophy 4 was a stopgap solution at best. But this wasn't just about fixing a problem. For John DeLorean, who had recently joined Pontiac as head of advanced engineering, this was an opportunity to do something extraordinary. DeLorean had come from Packard, where he'd worked in an environment that valued innovation and engineering excellence. At Pontiac, he found himself working under Bunky Knudsen and chief engineer Pete Estes, two men who were actively trying to transform Pontiac's stodgy image into something exciting and performance-oriented. They gave DeLorean something rare in the corporate world, a free hand to explore radical ideas. And DeLorean had his eye on Europe. In the early 1960s, overhead cam engines were standard fare in Europe, but practically unheard of in American production cars. Jaguar's legendary XK six-cylinder had dual overhead cams and had won Le Mans 5 times. Ferrari, Alfa Romeo, Mercedes-Benz, all of them were using overhead cam technology. Meanwhile, American automakers were still pushing pushrods and pretending that cubic inches could solve every problem. DeLorean and Pontiac's motor engineer Malcolm McKellar were particularly fascinated by the Mercedes-Benz M186 engine. This was the 3-liter six-cylinder that powered the Mercedes-Benz 300 sedans and, in more highly tuned form, the iconic 300 SL sports cars. It wasn't as exotic as Jaguar's twin-cam setup, but it had proven itself both on the road and on the racetrack. With its iron block and single overhead camshaft, it represented a practical compromise between performance, fuel economy, and manufacturing complexity. This became the conceptual starting point for Pontiac's design, but McKellar and his team weren't content to simply copy what Mercedes had done. They wanted to create something uniquely American, something that could be manufactured economically on a production line while still delivering the performance advantages of overhead cam technology. The advantages of an overhead cam design were clear. First, reduced valve train inertia. With pushrods, you're moving a lot of mass every time a valve opens and closes, the pushrod itself, the rocker arm, the lifter. All that weight limits how fast an engine can rev before the valve train starts floating and losing control. An overhead cam eliminates most of that, allowing higher engine speeds and better breathing. Second, you eliminate all those potential failure points. No push rods to bend, no lifters to collapse, no timing chains rattling around in the block. The cam sits right where the action is, directly actuating the valves through simple followers. And third, packaging. Without all that valve train hardware taking up space in the block, you could design a more compact, lighter engine. For a division trying to build sporty, nimble cars, that mattered. But there was one critical decision that would define this engine: how to drive the camshaft. Most overhead cam engines of the era used either a chain or a series of gears to drive the camshaft. Chains were proven, but added weight and created noise. Gears were durable, but expensive and also noisy. McKellar's team chose a third option that was virtually unheard of in automotive applications: a toothed timing belt. This wasn't just any belt. It was a 1-inch wide fiberglass reinforced rubber belt with cogged teeth on a 1/2-inch pitch. The same belt also drove the distributor, oil pump, and fuel pump via an auxiliary shaft mounted on the front of the engine. This was decades before Honda would popularize timing belts in American cars with the Civic and Accord. The beauty of the belt drive was its simplicity and quietness. No chain slap, no gear whine, just smooth, quiet operation. The entire assembly was mounted on a die-cast aluminum housing on the right side of the block, with provisions to adjust belt tension by moving the auxiliary shaft assembly up and down. Critics would later point out that timing belts require periodic replacement, unlike chains. But in 1965, this was genuinely innovative thinking. McKellar's team was trying to solve the traditional problems of overhead cam engines: noise, complexity, and cost, all at once. The camshaft itself lived in an aluminum cover that topped the engine. McKellar made the cam lobes twice as wide as conventional designs to reduce surface pressure and wear. The cam operated directly on hydraulic lash adjusters, which then pressed on the valve stems. This meant no valve adjustments, a huge advantage for the average consumer who might not even know what valve lash was, let alone how to adjust it. So, what did Pontiac end up with? The production engine displaced 230 cubic inches, achieved by boring the cylinders to 3.875 inches and stretching the stroke to 3.25 inches. From the head gasket down, it was essentially related to the old 215 cubic inch Tempest 6, but heavily revised. The block was a deep-skirted design, what some people call a Y-block configuration, which added rigidity and strength to the bottom end. In base form, with a single-barrel carburetor, the OHC6 produced 165 horsepower. That might not sound impressive today, but remember, this was 1966, and that 165 horsepower was coming from a smooth, refined six-cylinder that could actually rev. The base engine redline was a modest 5,000 RPM, but it would pull cleanly to that point without the valve-train chaos that plagued high-revving pushrod engines. But the real story was the Sprint option. The Sprint package transformed the OHC6 from a sensible economy engine into a genuine performance power plant. It started with a Rochester Quadrajet 4-barrel carburetor, the same excellent carb used on Pontiac's V8s. Compression jumped from 9.0 to 1 to 10.5 to 1, requiring premium fuel. The camshaft was more aggressive, with increased duration and lift. Valve springs were doubled up, an inner and outer spring on each valve to handle the increased pressure. The result was 207 horsepower at 5,200 RPM and 228 pound-feet of torque at 3,800 RPM. In gross horsepower terms, which is how engines were rated before 1972, that was legitimately impressive for a naturally aspirated six-cylinder. To put it in perspective, a base small-block Chevrolet 283 V8 in 1966 made 195 horsepower. The Sprint 6 was making more power than Chevy's base V8. For 1968, Pontiac enlarged the engine to 250 cubic inches by increasing the stroke, which brought base engine power up to 175 horsepower. The Sprint now made 215 horsepower with the automatic transmission. But here's where things got really interesting. For 1969, Pontiac introduced a high-output version of the Sprint for cars with manual transmissions. This engine produced 230 horsepower at 5,400 RPM and 260 pound-feet of torque at 3,600 RPM. The increase came from an even more radical camshaft with extended duration. Think about that for a moment. In 1969, you could buy a Pontiac Firebird with a 6-cylinder engine making 230 horsepower. That's more than many V8s of the era. Pontiac understood that bolting a hot engine into a standard car wasn't enough. The Sprint package was carefully engineered as a complete performance package. If you ordered the 4-barrel Sprint engine, you got mandatory heavy-duty suspension and tires, a 3.55-to-1 rear-axle ratio, or 3.23-to-1 if you ordered air conditioning, and Pontiac's Safety Track limited slip differential as standard equipment. The Sprint came with a 3-speed manual transmission as standard, with a 4-speed manual optional. Interestingly, the automatic transmission option, Buick's Super Turbine 300 2-speed, significantly blunted the car's performance. With the automatic, 0 to 60 times stretched out to around 12 seconds. But with the 4-speed manual and those 3.55 gears, a Sprint could hit 60 miles per hour in about 10 seconds flat and run the quarter mile in the high 15-second range. Now, those numbers might not sound earth-shattering today, but context matters. This was a 6-cylinder intermediate. It was competing against base V8 Mustangs and Camaros, and it was holding its own. More importantly, it was doing it with better weight distribution. That inline-six sat further back in the chassis than a V8 and better fuel economy. Road and Track magazine tested a Sprint and praised the engine's smoothness and refinement, but they also noted something interesting. The car felt heavy for its power output. At around 3,400 pounds, the Tempest and Le Mans weren't lightweights, and the Sprint engine, while powerful for a 6, still gave away significant torque to comparable V8s. The Sprint made around 228 pound-feet of torque, while a base 326 V8 made 300 plus. The OHC6 was offered from 1966 through 1969 as the standard base engine in 3 model lines. First, the Tempest and Le Mans Intermediates, where it all started. These were Pontiac's bread-and-butter A-body cars, competitors to the Chevelle and Cutlass. Having an overhead cam6 as the base engine gave Pontiac dealers something unique to talk about. Starting in 1967, the OHC6 became available in the Firebird, Pontiac's answer to the Mustang and Camaro. This is where the Sprint option really made sense. A Firebird Sprint with the 4-barrel OHC6 offered genuine performance with a level of mechanical sophistication that the base Mustang and Camaro 6s couldn't touch. It was a thinking person's pony car. Interestingly, the OHC6 was never offered in Pontiac's full-size cars, and it was never available in Canada except in the Firebird Sprint. Canadian market Pontiacs used Chevrolet's conventional pushrod 6 instead, likely because Pontiac didn't want to set up parallel production or service networks for a relatively low-volume engine. The Sprint option was typically packaged with other performance and appearance goodies. You got distinctive badging, often special striping, and an overall presentation that said, "This isn't your grandfather's 6-cylinder." So, if this engine was so advanced, why did it only last 4 years? The answer is complicated and involves a mix of technical issues, corporate politics, and market realities. The biggest problem was warranty claims. Early 1966 and 1967 engines suffered from premature camshaft wear. The camshaft would develop scoring and pitting, particularly on the lobes, which would lead to noisy operation and eventually valve train damage. The hydraulic lash adjusters could also stick or fail, causing clicking noises and poor performance. It turned out that the problem stemmed from three main sources. First, inconsistent manufacturing. Some engines came through the factory with incorrectly sized metering holes in the oil restrictor that controlled flow to the camshaft journals. If that hole was too large, it reduced oil pressure to the cam and lash adjusters. If the primary oil passage to the cam cover was clogged or machined incorrectly, that made things worse. Second, rough finishing on the contact area of the cam followers caused accelerated wear. This was a manufacturing quality control issue that should have been caught and corrected much earlier. Third, those little metal spring clips that held the lash adjusters to the cam followers during assembly, they were just supposed to be an assembly aid, but Pontiac left them in the finished engines. Occasionally, they'd break during operation and damage the cam or valves. These weren't fundamental design flaws. They were teething problems, manufacturing issues that could have been resolved with better quality control and continued development. And indeed, by the 1968 model year, most of these issues had been sorted out, but the damage to the engine's reputation was already done. The other problem was cost. The OHC6 was simply more expensive to manufacture than Chevrolet's conventional pushrod 6. That timing belt, the aluminum cam cover, the hydraulic lash adjusters, the die-cast auxiliary drive assembly, it all added up. In the penny-pinching world of corporate automotive manufacturing, where executives would cut corners to save $1 per car, the OHC6's added complexity was a target. And then there was the market reality. Americans wanted V8s. Despite the Sprint's genuine performance capabilities, most buyers saw six-cylinder and immediately dismissed it. Insurance rates, which were skyrocketing for muscle cars in the late 1960s, favored the six, but that wasn't enough to overcome the stigma. Why buy a sophisticated overhead cam 6 when you could get a simple, cheap pushrod 350 V8 for not much more money? What makes the OHC6 even more fascinating is what Pontiac almost did with the technology. Mac McKellar and his team didn't stop with the six-cylinder. They developed prototypes for overhead cam V8s based on Pontiac's famous 389 and 421 cubic inch engines. There was a single overhead cam 389 prototype that used a similar belt drive system scaled up for the V8. Even more exotic was a dual overhead cam version with 4 camshafts, 1 intake and 1 exhaust cam for each cylinder bank. These engines existed, they ran, and they were reportedly spectacular. Imagine a 1967 GTO or Firebird 400 with a DOHC V8. The performance would have been incredible. But corporate management was already nervous about how much power Pontiac was offering in production cars. They didn't need a NASCAR program where a hot overhead cam V8 would be useful, and the emissions certification challenges were mounting. The DOHC V8 project was shelved. But here's what really hurts. If GM had let Pontiac continue developing and refining the overhead cam engine family, they could have been in a commanding position when the oil crises of the 1970s hit. A properly developed OHC6 with fuel injection and modern engine management could have offered V8-like power with significantly better fuel economy. Instead, GM scrambled to adapt old pushrod designs, and we ended up with disasters like the Oldsmobile diesel. The technology was there. The engineering talent was there. What was missing was corporate vision and the willingness to invest in long-term development rather than short-term profits. The Pontiac OHC6 disappeared after the 1969 model year. It was replaced by Chevrolet's conventional 250 cubic inch pushrod 6, an engine that was cheaper, simpler, and utterly unremarkable. The overhead cam technology that Pontiac had pioneered wouldn't become mainstream in American cars for another 2 decades. Today, every engine from every manufacturer uses overhead cams. Even American pushrod V8s, like the Corvette's LT6, are now the exception rather than the rule. Timing belts, the technology that was so radical in 1966, became standard on millions of cars before eventually being replaced by more durable chains. For collectors and enthusiasts, the OHC6-equipped Pontiacs have become fascinating cult classics. A Firebird Sprint or Tempest Sprint with the high-output 4-barrel engine is genuinely rare. Production numbers were never huge, and many of these cars were later converted to V8 power by owners who didn't understand or appreciate what they had. The engines themselves are not easy to rebuild. That timing belt is long out of production, though aftermarket suppliers have developed replacements. The cam covers are aluminum and prone to cracking if improperly handled. The hydraulic lash adjusters require careful attention during reassembly. But for enthusiasts willing to put in the work, a properly built OHC6 is a revelation. Smooth, willing to rev, and genuinely quick in sprint trim. The Pontiac OHC6 represents both the best and worst of American automotive engineering. It was brilliant in concept, innovative in execution, and genuinely ahead of its time. But it was also let down by inconsistent quality control, inadequate corporate support, and a market that simply wasn't ready for it. It proved that America could innovate beyond pushrods and cubic inches. It showed that domestic engineers could match or exceed what Europe was doing with advanced engine technology. And it demonstrated that there was a market, even if small, for sophisticated, high-revving engines in American cars. The tragedy is that instead of building on this foundation, GM walked away from it. They had the template for a modern, efficient engine family, and they abandoned it in favor of short-term cost savings and the path of least resistance. The Pontiac OHC6 remains one of the most interesting what-if stories in American automotive history. It was the right engine at the wrong time, or perhaps in the wrong company. But for 4 short years, from 1966 to 1969, you could walk into a Pontiac dealer and buy a car with America's first mass-produced overhead cam engine. That's something worth remembering. If you've ever driven an OHC6, especially a Sprint, I'd love to hear about it in the comments. These engines are rare today, but they're a fascinating piece of automotive history that deserves to be remembered. Thanks for watching, and I'll see you in the next video.